excited to introduce Indika. He's the XR instructor manager at CircuitStream. He contributes to the development of education curriculum in both AR and VR. So if you're interested in asking a VR question, please do so. He manages the instructors and teaches AR and VR design and development. So thank you, Indika, for joining us. I'm going to stop my screen share and let you take over.
All right, thanks, Chanel. Cool, let me just share my screen. It's great to see that a lot of CircuitStream peeps are here. Hi, everyone. All right, can you see my screen? Righty. Awesome. Okay, so today's session is about UX for augmented reality. You know, like when it comes to augmented reality, you've been there, you've done that, right? So you know that when it comes to augmented reality, whatever the platform, whatever the channel that you present your ideas in AR, it doesn't matter for you user experience, right? So what matters is, you know, what sort of design principles that you can use in order to get your AR application or your AR presentation in a way that, you know, people who are experiencing it can experience in a way that, you know, it's, you know, that is soothing. All right. So what I'm going to do is, you know, I'm going to take like about a couple of minutes to kind of give you a very brief introduction to how AR works and, you know, what actually makes AR, right? And then I'm going to go over some 10 tips and tricks. So mostly the things that I'm going to explain are, you know, not too technical. So those are kind of like design guidelines and design practices that you can use in when you're building your AR application. If you want any support in terms of, all right, so how do I implement this in 8Vol? You can ask questions. So there are things that I know, like, you know, how to use Three.js, how to use, you know, certain JavaScript code to achieve some sort of, you know, design principles. But anyway, let's dive in. So when it comes to augmented reality, right? So what you basically see is an illusion, right? So you see the final output like this. Like, for example, you can see there's a table and you can see this 3D model of a, you know, of a tree. And also there's a 3D model of a plane that's on top of the table. But in reality, what happens is what camera sees is a plane, right? So what camera sees is like a, you know, like you're in front of a movie theater. And what the AR SDK, it could be 8Vol, or it could be Lightship, or it could be our foundation, or whatever it is, what it does is it has this virtual camera, which kind of captures the 3D model and the camera view and kind of align it with each other, right? And on top of that, the AR SDK has the ability to understand different virtual planes around. And these virtual planes will be placed in front of this, you know, theater, you know, screen. And then this camera, it kind of moves around within this virtual space. So as you can see here, right, you can see my, my cool example. The camera kind of moves around, moves in this virtual environment. Right? So when you move your actual device in this environment, you're basically moving it around this virtual plane, but the camera, the screen, it remains the same. So it kind of creates this illusion that you're seeing something in AR, right? So everything is an illusion. When it comes to AR, everything is an illusion. You have some sort of a trick going on, even if you don't know, you know, if you're using Niantic SDKs, you know, like, you know, there is some sort of illusion going on. So now, when it comes to Niantic, right, in terms of, instead of just understanding planes around, what you see here is a small example that I did. It is not 8Vol, it is AR Lightship ARDK, but it's pretty much the same backend. What it does is Niantic has this simultaneous localization and mapping, which we basically say SLAM, right? So SLAM and, you know, on top of that, we have some artificial intelligence going on to capture the world without a LiDAR sensor, right? So, you know, if you have a phone like this, you have this small LiDAR sensor that captures the world around you, but Niantic's ARDK and, you know, 8Vol has the capability to mesh the whole world around and creates this 3D mesh, which is kind of fascinating. It's the first in the world. I've never seen that. It's amazing, and that's what I love about Niantic. And it has given me a lot of opportunities to build things like this. And as you can see, you just throw balls, and at the same time, you're occluding everything, right? Occluding. You can throw something behind an object, and you can see that it goes behind that object. It's amazing. So this kind of opens up more opportunities to implement different kinds of AR applications, which leads to knowing certain UX principles, design practices and things like that, to make your experience better. So let's just go through, some of these you might definitely know, but you might forget to implement in your applications, right? So I'm just going to go ahead and pick like 10 tips and tricks and design principles that you can use in your AR applications to make your applications better in terms of user experience. Okay, so the first thing is, you don't want to be sued, right? Just because you made the AR application, right? So the first thing that you need to understand is, please inform the users about safety. There has been different situations where your AR application hasn't informed the users about certain safety features, right? So, people tend to sue, right? So please make sure that you give them certain guidelines. For example, in Google, if you open up the Google Map, the AR feature of Google Map, it's fun. You can just walk around just by looking at the screen. But you can identify, you can use the gyroscopic sensors, sensory data, and identify whether you're keeping on looking at the device. And occasionally inform the users about the safety. I can, for example, I can see that you're moving towards this junction. Please make sure that you're looking ahead, right? So don't, catching Pokemons are fun, but you have to stay behind the yellow line. Right? So don't go over the yellow line to catch a Pokemon on the train, on the railway station, right? Okay, so that is one thing that you need to keep in mind. So before opening up your AR experience, informed about safety. It can be anything, right? It can be just walking around with the phone, or maybe something else that that you can inform the users on. I know that Pokemon Go, it's very creative in terms of explaining how you want to go, how you want to move around. So yeah, use those principles to use those kind of coach marks to inform users about safety. So apart from safety, the other thing is you need to understand how this whole recognition works, right? So when we say SLAM, simultaneous localization and mapping, basically that means it uses your, it's just a camera input, right? It's just a flat screen, flat input that you get. So that flat input, whatever the flat input that you get, there is some sort of an algorithm that runs in the backend to understand whether this is a table or whether this is a tree or whatever it is. So what you have to do is you have to move your camera around so the algorithm can understand how things move around in the actual environment, and based on that it can guess, right, so this is a plane, this is a floor, this is a a tree, something like that, right? So you need to make sure that that you give some sort of visual effects, animations just like this, and don't make users feel lost of what to do. Just inform them through animations. A simple example that I'm showing right now here is that every gesture and every thing that they have to do within this AR environment, just let them know. So sometimes we call them as coach marks. We call them coach marks, and you can just do that by using animations. Exactly. But you don't really need to overwhelm users with a lot of stuff, right? So there are certain gestures that people already know. Just don't overwhelm. Just at the beginning, maybe just a couple of seconds of an interaction, a small thing, and you can also check whether whether there has been any input or not. And based on that, you can show them, for example, you haven't tapped the screen for a long time, right? So it seems like you're lost. You have to do this, or do that, pinch, things like that. So always use visual instructions, because they are really important to make your AR experience better for the end users who are actually, they're the ones who are actually using it. Cool. And then another one, what do you call these? Our boxes of instructions. We call them coach marks, right? Coach marks. Let me just type it over here. Coach marks. I mean, coach marks is it's like you use, if you are a UI designer, you use coach marks before, in your applications to kind of navigate the user, to show them how to do it, right? Okay. So the other one is, I've seen this in some AR effects as well. You create tiny objects, right? You scan the world around, all right? So you scan it, and then you can see a small tiny object, somewhere far, far away. So don't do that, right? You can do that, but you need to be able to kind of explain why it is small. But if your AR experience is not small, not big enough, users will have a hard time to explore, right? So augmented reality is all about exploring, right? What it gives us, rather than just a normal 3D application, is that it gives us the flexibility, the freedom to move the camera around, right? So what you need to make sure is that your AR experience is bigger and has, room for exploration. Because that is, AR, the biggest thing in AR is curiosity and the immersiveness. So in order to get that immersiveness, make your items big enough so that people can explore, right? So as you can see, this small example, there is this 3D plane, which was a little bit smaller. It's a teeny tiny object, but make them bigger so that the user has more flexibility to explore around the AR experience, right? And and it's fun, if your experience is bigger and if there's more room, more stuff to explore, it's always amazing to just move around the camera and explore things. Okay. Now the other thing is, of course, sometimes you can make things explore, but sometimes there will be certain experiences that you create where you have to actually follow something, like something like this. You open up the camera, your AR experience, it asks the user to open the camera. And the moment that it opens the camera, it doesn't actually show the biggest, the biggest 3D models in the world, right? So what it might usually do is maybe, have a butterfly, something like this, that flies around you. So a user could be lost. Oh my God, what the hell am I looking at, right? So as you can see here, this butterfly is going to fly away at any moment. There you go. The butterfly flew away. Always use visual markers. So as you can see in your right-hand side, the butterfly flew away, but make sure that users turn their cameras towards the butterfly, and you can do that by using a visual marker, right? And as you can see here, now the butterfly will fly to the left side, and make sure that the marker, the visual marker moves to the left side, right? So that way we know, all right, so there you go, right? So, like in games where you can see the enemy, the direction the enemy is shooting at you, just do the same thing. The easiest way to do that is to check the distance, the direction from that particular object to the camera. And you might have to do a little bit of mathematical calculations to get it, around the screen. So you can map the distance, you can map the direction, and take it to the screen space. Screen space is what you see over here. If this is the screen, this is what you see. This is the screen space. And make sure that you move your visual marker around the screen so that it stays in the in the screen, and it helps the user to look around. Okay. The fifth one is that you need to be mindful about the scale, right? With Niantic, this is really easy because Niantic itself has a native way of scaling objects. But like, for example, if you're creating an AR application which runs on a tabletop, you need to make sure that your camera and your objects are scaled, according to that size. And if it moves to, let's say, a room, then the scale that you used on your tabletop, it doesn't actually match the room, right? So you have to scale it up. And sometimes when you're scaling up, don't scale up the whole set of objects. Because when you scale objects, technically, it's going to make things really hard because your particle system has to be, scaled up. All of your objects has to be scaled up. So instead of scaling up the whole object, find a way to kind of make the camera closer to the object, right? So what you can do is basically you can increase the scale of the camera, right? When you increase the scale of the camera, it automatically scales the objects because usually the camera kind of gets closer, right? So what we are trying to understand is scaling all the objects versus scaling the camera, right? So when it comes to Niantic 8-volt, there's this concept called absolute scale. So like, for example, if you're making an application where you configure a car, you definitely cannot allow the users to scale the car up and down, right? It doesn't make sense because, the idea of the main reason why we are using AR is to get a better understanding about the scale. And if we allow the users to scale the object, and it doesn't really make sense, right? So if you're creating an AR application that actually uses the real-time, real-world scales, make sure that you use absolute scale with 8-volt, and you will be able to, scale it up to 100%, which means it is the actual scale in actual, scaling units. Awesome. Now, there is one other thing. So this is something that I usually implement when I create my applications. I don't want users to peek, and you shouldn't as well. Because when you're creating 3D, any sort of 3D application, you have certain tips and tricks that makes things work, right? So if you're building games, if you're into game development, and if a character kind of moves into a room, you don't really move the actual character inside the room because the gamer doesn't actually see what's happening. So instead of that, you just visualize, or maybe, if there is a mountain far away, you just have sort of tricks to show that it's an actual mountain, not actually a 3D model. So those kind of tricks are possible in games, because in games you can make restrictions where the player moves. But when it comes to AR, like, we've given 100% flexibility for the for the user to move the camera around, right? So I have my camera, right? So I have I have unlimited degree of freedom to move my camera all around, which makes me peek inside what's happening inside of this. Let's just say you're making a you're making a puzzle game, and you're supposed to open this and explore what's inside, right? And the task is to open it, right? So instead of opening it, you just peek inside, you just move your camera inside the 3D model and see what's going on, right? So, the derpy Batman would wonder what's inside this stuff and slowly move inside, peek inside. And we need to understand, we can use collision detection, or we can use the distance measures with the camera, because now the Batman is the camera, right? Batman, it's not the Batman, it's you, it's the user who's doing this, and it is the camera. So what you can do is you can use collision detection, or you can measure the distance between the camera and that specific object, and you can block it using the user interface, right? One example is, this is possible in VR applications as well, right? In VR applications also, you can move your head, and you have this unlimited flexibility. If you move away from the room, right, you shouldn't be able to see what's outside the room. So either you black it out, or you just ask the user to go back into the room. So you can do that, right? For example, when you peek inside a certain object, you can see, instead of actually showing what's going on, you can just give a notice saying, please move your camera out of this area. Or maybe you can blur it, you can black it out. So this is something that I usually add. It's something that you can also consider to make your AR experience seamless, right? Because if users kind of understand your tips and tricks, their immersion kind of gets lost. Awesome. Now, I'm just going to quickly go through this manipulation of objects. This is something that you already know. It's something that is native to Niantic 8-volt, right? Something that you can, natively implement. manipulating objects. So, like for example, if you go to Amazon, you can download, you can see how a certain object would look like, right? For example, in IKEA Place, you can just place a furniture and see how it's, how it works. And there are some AR experiences that allows you to tap and place multiple objects around the world and ask the user to, interact with it, manipulate the object, move things around, right? So you can do it in very different ways, but depending on, the user experience research done by Google with the AR core, they've said that, there are certain gestures that you can use, that you can reuse in order to make it a little bit more seamless, right? For example, let's just say that we have two different AR objects in the space, right? Two different objects are in the space, and you want to move one around, right? So if you try to just tap on the screen without tapping on the object itself, right, it may not move. One thing that you can do is you can ask the users to first tap the object that you want to move, and then use a visual indicator, indicating that, that specific object has been selected. And then what you can do is, of course, right, so just like this, you can either tap this or this to move around. And then once you're tapped, then you can drag and move the item on the screen. So on your screen space, what you're doing is this. You're basically moving your finger across the screen, right? For all the gestures, this is the only space you have to move it across the screen. When your object is selected and you drag on the object, right? Not the screen. If you drag on the object, the selected object, then it would move along the plane that it's already in. It will not go up, it will not go down, it will move along the space that it's, it's placed. And let's just say you want to scale. This is pretty simple. If you want to scale an object, just pinch on the object to scale it up and scale it down, right? So you can use the pinch to scale it down, right? And scale it up. And then the other thing is, now we need to say, all right, so when you are moving, when you're moving your finger across the screen, now how do we actually rotate this, right? Because when you try to rotate it, it will move, right? So you have to distinguish between those two gestures. So one widely used gesture that I've seen that, that is also recommended by Google is to, all right, select the object, and then instead of tapping on the object, tap somewhere else and move it across the screen like this. And when you do that, the object that is already being selected, and that you're kind of swiping across the screen, and then you can use that gesture to set the rotation of the object, right? So if you're implementing your custom gestures, you can do that. Yes. Can you tap to select and swipe? So you tap to select, and then you drag on the object to move, and then you drag out of the object to rotate, right? So usually it is always good to use question marks to, ask users to do that, because, like most of the users who are actually using this, they're not used to it, right? If you're creating your own AR gesture, they're not used to it. So you have to make it you have to kind of show it in a way. You can use question marks, or you can use, some other way of interaction to inform the users what to do. Don't make them feel lost on what they have to do, right? Just don't just show a 3D model and just do that. Just do some sort of an interaction, inform the users on how you manipulate, how you interact with it. Yes. Okay, so now let's just say that you have an object that looks like this, right? And there is a chance that you move away from this object, right? You would be moving further away from this object. When you move further away from this object, the size, the scale of the object, in your perspective, it gets smaller, right? So as you can see here, right now over here, it's big. But when you move further away, the touch area of the object is small. And let's just say that in your application, you're supposed to tap it, and you're supposed to kind of, interact with it, even in a far distance. So what you can do is, this is something that is not like inbuilt This is something that you have to kind of, improvise and create in your own way. When you move further away from the camera, just check the distance from the object to the camera. And if it has some sort of a ray casting, or we call it, an event trigger or a touch trigger, make sure that the touch area of that object is bigger, right? So there is a VR, it's not AR, there is a VR game called I Expect You to Die. It has this, just search for it, it's my favorite VR game. It has this telekinesis feature where you can grab an object from a distance. And it has this small reticle, which has some sort of a touch area where you, if you kind of focus it to an object near you, it's so small. It is small, right? You can see it as a small object. But if you move it further away, the reticle or the cursor, it becomes bigger, because if you keep it small, you might not be able to see it, in a distance. So make sure that, if you're moving further away, if you have interactive elements, right? Or if you have some sort of reticles, things like that, that you want your users to see, make sure to make them bigger, right? So if you're just using, if you're just building what is default to 8-volt or ARDK, sometimes you may not get this feature out of the box, right? So these things, to improve the interactivity, to improve the seamless interaction of your application, just make sure that you consider the touch areas and the reticles that you put in your application. Awesome. Now the other thing, visual cues for everything, right? If you want users to interact with the button, if you want users to interact with some sort of something else, right? Make sure that you have visual markers, right? Use tooltips, arrows, small curved lines, animations, things like that, to kind of distract the user, towards that certain interaction. In game design, let's just say that the user or the player has to go to a certain door, and there are hundreds of doors in a hallway, right? So usually, game designers, they would just put a small spotlight above the door, so that players would understand, oh, this is the door to my goal, to my end goal, right? So just like that, use certain different visual markers that, to the objects that are interactable. Just don't visual cue everything, right? So if it is not interactable, just, there's no point of adding a visual cue. But make sure that you have small tooltips and things like that in your application to make it, so that people would understand, oh, this is some place that I need to tap, right? Awesome. Now, another example of using a visual marker, visual cue, is to represent things that you cannot represent in an AR application. Like, for example, this one right here, right? Let's just say that you're supposed to, don't think of it as a fishing pole, right? Just imagine it as a virtual fishing pole that you tap and then you drag around, right? Like in my previous example that I showed you, you can move objects, you can rotate objects, you can select objects. One thing that you cannot do is you cannot lift the object, right? What you can do is to use a line renderer, right? Use a small line renderer, and you curve it so that you can visualize a certain feature of that object. So I'm going to quickly show you, the example, and I'm going to ask a quick question. What would that be? What would that, property that you're trying to visualize with this, right? So by default, it would look like this. And when you lift it up, it looks like this, right? So can anybody guess, like, what is the property that I, as an AR designer, what is the property that I want users to understand? Just think of it as a fishing pole. You have this line renderer. There you go. I got one answer, right? Yes. So you can use visual cues to, fishing pole. I mean, yes, to bring it closer. And if you want to bring it closer, just bend this line a lot so that users would understand, oh my God, this is not an object that I can easily just move around. It has a weight, right? So I have to carefully lift it up and I have to carefully move. So that kind of gives that immersive feeling, because you're kind of using a virtual fishing pole to lift that object up, right? Awesome. So the final thing that I want to talk about today is, okay, so user experience is not all about user interfaces, but user interfaces definitely are part of user experience, right? So I've seen in a lot of AR applications, when you open up the AR application, what you see are a bunch of UI elements all around the screen, right? So you have one over here, you have the logo in the middle, you have some sort of a deck over here, you have something over here. But when it comes to user interfaces, what you need to understand is, like, you're making an AR game. You're not making a normal game. Why you're making an AR game is you want users to feel this, immersiveness. And you do that, and at the same time, you block them out of their view, right? So make sure to use minimum amount of user interfaces on the screen. So we call this, user interfaces on the screen, we call them screen space UI, right? Of course, you can, because you're using 8Vol for web applications, you definitely can embed your applications in certain, in your own website, right? And you can definitely use any other JavaScript framework to build user interfaces. But because you are using either 3JS or Play Canvas, so A-Frame, all of these 3D frameworks, they have the capability to create world space user interfaces. So what is a world space UI? The first principle is, make things small. Make things minimal. Don't add a lot of UI. And the other thing is, just don't use the screen space, because this will avoid, like, if I'm looking at this butterfly and I'm enjoying this, I'm enjoying the view of this butterfly, and all of a sudden a UI pops in saying that I want something, you know what? I don't want to win. I'm just I'm just experiencing this. I'm just interacting with this. I don't want a screen space UI. I don't want a UI in screen space. But what we can do is we can create a world space UI. A world space UI is where you move whatever that you put on the screen to here, right? So your user interface, instead of being like, right pinned on top of your screen, it will be there in the world. So, users can explore what's going on. Users can see. And the coolest part is you have unlimited space to show things, right? On a screen, you have just the screen, and you cannot do anything. It's limited space, but in world space, you have a lot of space, right? So that's why we call it world space. So I'm showing a couple of examples that are created using Niantic 8Vol. And right here, you can see this, this is the only screen space UI in this example. And this is the world space UI, right? So use world space user interfaces to make things, look nice and, allow users to explore. All right, so that actually ends the 10 tips and tricks and design principles that you can use in order to make your AR filter or AR application better. Thank you so much. There you go. There's your butterfly.
Thank you so much, Indika. And I think this butterfly was like a very nice co-presenter with you. Everyone was really happy to see the butterfly's journey and that it's still alive. Thank you so much for bringing the butterfly black. And I know that I learned lots of things from your presentation, and I know we have lots of questions ready. So along with Indika today, doing the presentation, and Indika will be answering questions. We also have Evan and Ian, the 8Wall developer support engineers, answer more 8Wall specific questions, just to let you know that. But yeah, here is the QR code if you want to scan it again on your phone so that you can look at the questions that are being submitted. You can upvote the questions. And I'm going to start off with some questions that we already have in Slido. So one of the questions we have here, and like Indika, you can try to answer it if you want Evan or Ian to answer it, just say so. But the first question is, can either 8Wall or Lightship pull assets from a database and load them into a template?
Assets in the sense, what you can definitely do is, because you're using 3JS, you're using, like a WebGL 3D framework. And these frameworks, it has the native capability to use, to import any sort of a 3D model that is supported, definitely. For example, an FBX file or a GLB file. You can put them in a third-party storage, and then you can import them dynamically based on your application. Like, for example, you can use Google Bucket, Google Storage, or Amazon S3 to store your 3D models, and you can import them. And also, if you're using 8Wall, 8Wall itself has hosting, right? So you can definitely upload them to 8Wall. That is something that you do by default. But yes, because you're using you're using a separate 3D framework on top of it. Yes, you can import them using a separate link.
If I could just add on to that. Thank you. 8Wall experiences are just standard client-side web pages. So you would do this very similar to how you would on a normal web page. Just make a fetch request to an endpoint to download your asset and just load it onto the web page.
Amazing answers from both Indika and Evan. Thank you so much for answering that question. And the next question is, how precise is 8Wall in terms of location?
So based on my experience, 8Wall, it has VPS, right? So as far as I've tried many AR frameworks. When it comes to WebAR, 8Wall's VPS has it uses its own localization framework, and it uses your location. And on top of that, you can, it has this, globally scanned environments, which you can load, and you can create your AR experience in that specific environment, right? So you can use VPS. And I've tried VPS, and it's accurate to the to the centimeter. I've tried it. It depends on your lighting, of course. It is super incredible. It depends on your lighting. If you're scanning this in a very low light environment, of course it can glitch a little bit. But location wise and tracking the environment wise, Niantic 8Wall does a very, very good job.
Awesome. Yeah, thank you. I think you answered that question very well, Indika. Let's move on to the next question. So I know that you talked a lot about coach marks. Might have been a new term for some people, but I think it's a really relevant term. Some people are curious about, how do you use coach marks in 8Wall? Is it an object? Can you describe that a little bit more?
So it definitely depends on your AR application situation. So, like I explained, you can use screen space UI, where you put this, your element on the screen space. And yes, you can use world space UI as well. So this UI in 3JS or in any 3D engine, it could be an image that is in the 3D world, right? It could be like, if you're using web, you can definitely create a UI on top of that, and you can use any front-end framework. You can use React.js to show the coach marks, right? But you don't want to overpopulate everything that's on top of the screen. Just make sure things are minimal. And if you want to show something on an object, AR object, you can create a tooltip image, right? You can texture a small image, and you can put it on top of the that object as a visual coach mark. And to guide the user, you can use that visual marker, right? So either you want to turn left or to turn right, just check the distance and show that on the screen. So that is screen space, and the tooltip is in world space. You can do that. So, an image or just using standard CSS. Yes, it is possible.
Amazing. Yeah, thank you so much for giving us the answer. And I think another thing that you mentioned a lot were gestures to use in WebAR experiences to create better user design and experience. Can you talk more about, like, is there a library document that describes accepted gestures in the AR application?
In terms of a library, I haven't actually used an existing library that is allowing you to create gestures. Usually what we do is we get the touch input. Of course, because we are handling multi-touch interfaces, we can get the array, we can get a list of all the touch points, and you can get the screen space touch points, right? So like, for example, if you're getting just one touch point and you track the touch points movement, and when you release it, you can track that as well, right? So that you can do on top of web, right? It's pure JavaScript. You can get the input position, basically the touch position. So based on your touch position movement, if it is a y-axis movement, sorry for being a little bit more mathematic. If it is a y-axis movement, that means you are swiping up. If it is a negative y-axis movement, that means you are swiping down, right? If you have more than one touch point, and if the distance between those two touch points increases, that means you're kind of pinching up and down, right? So you can check. So for that, definitely you can use a separate method. You can create a separate JavaScript method to check that. And my suggestion is to make your own thing, because it's very easy for you to customize. Libraries, I haven't actually used a lot of libraries to get the touch gestures. Any good examples you'd recommend for 3D text? I can see a small question over here. For 3D text, I think 3JS itself has a very good library that you can like import any sort of a font and make it 3D, right? And so I can vouch for 3JS because that is something that I've used. So in 3JS, it has its own way of creating 3D objects, and you can choose whatever the text you want, and you can texture it. You can add materials. You can add your own materials into that text. But having a lot of 3D models in an AR space also hinders the sorry, my bad. In terms of the performance, right? So don't add like, huge high poly fonts and high poly 3D models. Make sure that you use the minimum amount of materials in your application. So like performance wise, I mean, you don't want your AR application to lag, right? So use the minimum amount of materials as much as possible. And when it comes to minimum amount of materials, you can use just one material with just one texture, right? I'm not sure if everybody is, everybody know like how to design 3D models, but if you're creating your own 3D model for your own AR application, it gives you a lot of flexibility to improve the performance of your application. Like, for example, if you're using like 100 different 3D models in your application, and if you have all of the textures of the 3D models are mapped into just one texture and one material, and we have this concept called UV maps. It's a technical term. If you don't know it, just search for UV maps. And if the UV maps are properly in that specific texture, then your like 8-volt just have to import just one material, and it just has to render just one material. And your whole experience is going to be much better because it doesn't have to render a lot of materials and objects every frame. It's just one material. So everything is just pops in, and your AR experience is much more smoother. So yeah, so that is actually something additional in terms of performance.
Amazing. Thank you so much, Indika, for answering that question. And I have another question. You kind of touched on 3D models already. Maybe you can dive a bit deeper, and maybe Ian wants to jump in as well. But what kind of asset is used for an animated 3D object, and possibly like what kind of optimization for 3D assets should be used?
So in my experience, usually use like low poly assets, low poly 3D models. If you're using FBX, like if you're used to Blender, you can embed the animations into the object, or you can use a separate animation. But like how to make it seamless is one way is to have all the animations in one animation file. And in Three.js and in all the Web 3D frameworks, you can chunk the animations into different numbers, right? For example, from frame 1 to frame 100, it's running animation. From 101 to 120, it's a jumping animation. So you can use tools like Blender to merge the animations together into just one animation. And usually I'd recommend FBX, but if even if you have any other recommendations, I'm happy to learn here as well.
Yeah, no, you can certainly bake animations into 3D models. And one really useful software that people use is called Mixamo, especially if you're using kind of a humanoid rig. And what this does is you can auto rig a 3D model you have, and people use this a lot if they're doing a joystick project where they're like walking a character or something, and using Mixamo you can rig walking animations or idle animations, and this is kind of like a really easy way to rig or animate a 3D model. I know I've rigged models in the past, and it's kind of a rigorous long thing to do, and Mixamo has made it really easy to animate objects. And 8Wall, we use kind of like a GLB, GLTF file type, mostly if you're uploading to the 8Wall Cloud Editor. And this is kind of a web-based, really optimized type of 3D model. And it works as long as you have the animation baked into it. So kind of some tips there.
Amazing. Thank you so much for answering that question. And then we have a few minutes left, and I think this is a really great question. It's for Indy to answer, but also maybe our 8Wall team, Evan or Ian, to give some other additional 8Wall specific tips. But because you are an XR instructor, Indika, can you suggest a rough roadmap for learning things for AR beginners?
So when it comes to AR, like there are certain channels, right? So I used Unity as my first step into AR because it had this amazing set of packages, flexibility to build AR applications. So I would say if you're stepping into this, use whatever the tool that you can learn easily, because the principle is pretty much the same. Either it is 8Wall or it's Unity using ARDK. It is the same principle. So first of all, I think it would be better if you want to know, if you can understand how the whole 3D interactions work, right? How 3D works, first of all, right? What are materials? How you can apply materials, textures, how 3D models work, how animations work. Then you can move on to if you're building WebAR applications, because I kind of feel that WebAR is kind of the future, because people don't want to actually download just separate application to experience just one filter, right? So they have to have immediate access to something, experiencing it, and then they have to forget about it. So WebAR is going to be the future as well. So if you're stepping into WebAR, I would recommend learning a WebGL framework. You don't really need to learn WebGL from WebGL. It's a little bit hard. I don't even know it, but you can start with Three.js. It's a very good high-end, high-level API that you can build a very simple AR application pretty quickly. Sorry, 3D application pretty quickly. And also, I would recommend A-Frame. A-Frame, it's a little bit different. It uses HTML tags to populate every object in the canvas. And if you want more control, yes, you can use Three.js, Babylon.js, all the JS frameworks, they use WebGL in the, underneath. So you can choose, you can try all of these separately. You can understand, all right, so I think Three.js is good for me. I'm just going to go ahead with this. Or maybe if you feel like A-Frame is easier for you to understand, then stick to that. Don't try to move in between Babylon, A-frame, because it makes things a lot harder and you're just lost trying to do everything. Just start with something and stick with it. A-frame is, I would recommend A-frame for complete beginners to understand WebGL. And then, of course, you can jump into AR using Niantic. Because now Niantic 8Vol, it gives the base platforms to the platform to integrate AR features into your existing A-frame application. So let's just say you create an A-frame or 3JS 3D application and you want to make the whole world AR, and you just have to grab the same thing and put it into 8Vol and do a little bit of configurations to get 8Vol running within A-frame. So it's the same code, same way of adding 3D models and objects. So if you're really new to this field, I'd recommend you start learning about 3D and how 3D works. Because for some people, it's really hard to understand, the context. So understand that, and then it's going to be really easy for you to understand what's happening in AR. So that is why I started the session showing you what actually happens in AR, right? You have this screen, and then you have the object in front, and you have this camera. It creates that illusion. So first of all, you focus on what's in the middle, and then you can figure out how to add that screen behind your AR, behind your 3D interaction.